Hi, so welcome back to another video, and in this lesson we're going to go over the review for linear regression and correlation. So a precursor, or maybe I should say a word of caution. This exam is very calculator heavy, which is good, which is always good for us, right? It's very p-value heavy, so if you can find the p-value, you can tell if there is a correlation or not, things like that. I'm going to show you guys how to use the calculator. On the exam, I don't believe you're able to use StatCrunch, so this is going to be pretty TI-84 heavy. But anyway, let's jump in. So I'm only going to do the ones that I know are very, very similar to the ones on the exam. I think that'll be the most helpful to you. That way, it's not going to waste your time. If you follow this video, you should do very well in your exam. All right. Anyway, so let's take a look at the first one. So we have, it says 20 different statistics students are randomly selected. This is question number 1 from the review, and this question was definitely on the exam. All right, so yeah, so go ahead. You can tell they're somewhat conceptual, right? It says choose the correct answer below. It says for this sample of paired data, what does R represent? And what does rho represent? That's the Greek letter rho. It looks like a P. Yeah, this is the answer. Okay, so you can, write this down, jot it down. This is basically the definition of R and rho. So R is a statistic that represents the value of the linear correlation coefficient computed from pair sample data. And rho is a parameter that represents the value of the linear correlation coefficient. That would be blah, blah, blah. You get the idea. All right. Maybe I should say something along the lines of these questions were very, very similar to what's on the exam. Make sure you get this one correct as well. If it has no correlation, that basically means that your R is equal to 0. A strong correlation will be either very, very close to +1 or -1. So for this particular question, if there's no correlation between them, and very, very tricky verbiage that they're going to throw here as well. It says without doing any research or calculations, estimate the value of R. So basically, it's like they take a commonsensical approach to this, and I hate when they try to throw something like that in mathematics, something that's commonsensical. You have to know this. You have to, I guess, somewhat be cognizant of the subject matter. They're talking about body temperature and head circumference. Now, they're assuming that there is no correlation between the two, like there's no relationship between them. So if there is no correlation between them, that means that the data would be scattered around everywhere. There's no pattern. There's no straight line, nothing. So you would say that the R would be 0 because there would be no relationship, no natural relationship between the two. But that's arguable. But anyway, and because there's no correlation, you want to choose 0 as your number. So this is going to be on the exam. I saw it. Anyway, C, choose the correct answer below. They're talking about this up here. It says, does R change if body temperature are converted to Fahrenheit degrees? The answer is no. Okay, so you want to write this down. The value of R does not change because R is not affected by converting all value, to a different scale. So you want to get those are easy points. You want those. Okay, so definitely question 1 is going to be on your exam. I also have question number 4 as a highlighted question. Yeah, this question here is definitely going to be in your exam. So I'm just gonna go ahead and open this up. So you see we have all the different scatter plots there. First and foremost, you see scatter plot number 4. That's almost a straight line, right? And you see as we go from left to right, it's falling down. That's going to be negative. So will this one. That will also be negative. And that this is going upwards, so that's going to be positive. So you want to know the difference between positive and negative correlations. So if it's going upwards, towards that side, going up and to the right, that's positive. If it's going down to the left, I'm sorry, down to the right, that is negative. So rising is positive, falling is negative, okay? Just drill that in your brain. Now, I brought attention to scatter plot number 4 because that's almost a straight line. Actually, it is a straight line. If you were to draw a line, it'll go through all of them perfectly. Whenever you see those, it's either going to be positive 1 or negative 1. So you can see right here where we have scatter plot 4. That's a perfect negative 1. And remember, it's negative because it's falling down as we go from left to right. Okay. So if you see a straight line, go ahead and make your answer choice as negative 1. Okay. If it's going upwards, if it's positive, make it to a positive 1. Now, take a look at scatter plot number 1. It's very, very similar to 4, right? So, but the thing is not as, I guess, the numbers aren't as close, right? You can see these are definitely, you can run a line through all of them, right? But that straight line, if you were to run it here, it will not quite make it to each of them, but is very, very close to 1 to negative 1. So you want to choose negative 0.996. It's as if you're comparing these two. Scatter plot 4 will have a stronger correlation. So that's right on the money. It's negative 1. But this, not so much, but it's still pretty darn strong. But close but no cigar. So you're going to have to say this is negative 0.996. And yes, once again, that will be on your exam. This is actually very similar to, so scatter plot number 3 is very, very similar to scatter plot number 1, right? So the only difference is the sign. So this should be positive 0.996, and yes, it is. You can see we already have it here. We already completed these. Let's take a look at number 2 and scatter plot number 5, right? They're all over the place. So these numbers should not be close to negative 1 or positive 1. These are, it's like there's a very, very weak correlation. And the question is, is it going to be positive or negative? Be very, very careful. Okay, let's take a look at let's take a look at number 5, for example, scatter plot 5. So you can see these numbers are kind of falling down. You can see we have one lone value here. We have another point here. These values are falling, so it has to be negative for scatter plot 5. Same thing here. You don't have any points up here, so it can't be rising. Once again, these are also falling. So both of these for scatter plot number 2 and scatter plot 5, they should be negative. So it's like, okay, which one is stronger? Which one is closer to negative 1, right? So basically, these numbers right here are a lot closer than these numbers. These are way more scattered than these. So in scatter plot number 2, these are far more scattered than what you have in scatter plot number 5. So these numbers should reflect that. So for scatter plot 5, it should be stronger. It should be closer to negative 1. So that's why we have 0.72. 0.72 is definitely closer, right? As opposed to scatter plot number 2, which is all over the place even more. That should be closer to 0. And that's why scatter plot number 2 would be negative 0.375 is not as strong as this one. So you can jot these down. You can study these. You can do similar exercise until you get the idea. And that's all there is to it with the analyzation of the graphs. So let me see. What do we have? We have number 5 is definitely going to be on your exam. And I will show you how to handle these in your calculator. So let me open up the calculator right quick. Okay, there we go. So what do we have? How do we even get this? Okay, so let me make sure you guys can even see. Yeah, you can see. Okay, so let's go ahead and make this fancy graph. You can see I already have the answers here, but let me show you how to get it from scratch. First, you go to your trusty stat button. You're going to hit enter on edit, and you basically put in all of these data sets. So they were nice enough to say that the top row is going to, the top column is going to be X. The bottom column is going to be Y. Always make your X your L1. So we're just going to put in all the numbers. So we have 10, we have 8, we have 13, we have 9, we have 11, 14, 6, 4, 12, 7, and 5. All right, we're gonna do the same thing for the bottom row. We have 9.14, 8.14, 8.75, 8.77, 9.27, oops, 8.09, 6.13, 3.09, 9.12, 7.26, and 4.73. All right, so this is what you're mostly going to be doing in your exam. Let's hit second and quit so that there's no funny business. So we exit out. Now, to get this graph, and it's very, it's crucial that you pay attention here. You can rewind. I'm trying to, there we go. Okay, I had to click on it to actually, I'm not sure. Yeah, you can see like the answer is D, right? I want you to basically, I'm going to show you how to navigate your calculator to set it up so you can get the proper graphs and everything like that. So basically what you want to do. All right, let's see if we hit the graph button, will it pop up? No, it didn't quite pop up. So here's what we're going to do. You hit second and you click right up here. It says stat plot. Go ahead and click on that. And you end up with this little menu. And for number 1, we want to turn that on. So let's hit enter. And we're going to hit the on button. So you see we have on and off. So we want to click on. And they're going to ask you, okay, what type of plot do you want to make? So we have all these different kinds of plots. You want to choose the one with the dots, the very first one. That's the stat plot. And you should be good from here. You leave this as L1 for your X list. Leave that as L2. Just once you do this the first time, you don't ever have to come up here and change it again. Okay. You can change that to whatever you want, or you can just leave it alone just to be safe. Let's hit second quit. And then when we hit graph, we have something like that. So we can tell that is D, right? It's kind of curvy, but we can't quite tell. Let's say we're not. I know it's D because I've done this a couple of times, but let's set it up so the window looks exactly like what we have here in the multiple choice. So to set that up, you're going to go to window, and you see all this stuff is asking you, what is your X min? So looking over here at your, let's take a look over here at your actual graphs here. Like you see your scales, they look at your x-axis. Your x-axis goes from left to right, and your y-axis goes up and down, right? So let's focus on the smallest x, your x min. What is your smallest x here? Your smallest x is going to be 0. So you're going to go back to your calculator and type in 0 for your x min. Your x max is whatever the number on the right side is, 16. So you can set it to 16. X, I believe SCL stands for scale. Just leave it as 1. Yeah, you can leave it as 1 if you want. Or you can follow them. Not make it complicated, just leave it as 1. You should be okay with 1. But technically the X scale here, because every increment here in the graph is 2, the X scale here will be 2. That will make it look even more precise. But you know what? Just leave it as 1. You can't go wrong with 1. Always just leave it as 1 just to make it easier on you. All right, for your Y min, whatever your smallest Y here is on your Y axis, that starts at 0. So put a 0. And what's the top number? The top number is 10. So put a 10. All right, once again, just for simplicity, leave your Y scale as 1. And now we're in business. Go ahead and hit graph, and you're going to see it looks exactly like our choice D right here. So D is definitely your answer. We're done with that. That's how you find your graph. So if you set up your calculator with the stat plot, so second stat plot, and you already have this turned on, you don't have to go here anymore. You can just go to stats, go to edit, and whatever list you put in for L1 and L2, once you put them all in, you hit graph, and there's your graph. And you can use this for the remainder of your exam and for the remainder of your course, as long as you don't change those settings. Okay. But anyway, yeah. So you always want to, adjust your window based on the graph you see here. And let's go ahead and get all the other good stuff, like your linear correlation coefficient R. So there's a calculator function for that. All you do is go to stat. You go over to tests. And I'm going to hit the up arrow so I can go to linear regression t-test, lenreg t-test, okay? So we're going to go ahead and hit enter. And leave everything the same. Make sure that's L1, make sure that's L2. And your calculator shouldn't be changed unless you let someone borrow it. Leave that as 1, leave this as equal to, or I should say cannot equal to 0. It's always going to be that. Leave that blank. Just go all the way down to calculate. And look at all this good stuff, right? So we came here for, for the regression line, which is coming up later. You see at the very top, it says y equals a plus bx. They're going to ask you to find equations. And look, you already have your a, which is 2.99. That would be your intercept, your y-intercept. And then you already have your b, which will go next to your x, which is 0.50. So when they ask you to round, be very careful as well. They may ask you to round 1 decimal place for your A, but then 3 decimal places for your B. So be careful to read up on those. You don't want to miss those. Anyway, we came here for your R. Go all the way down, and there it is, 0.816. So in our answer, we put 0.815, but hey, it's the same. So don't trip yourself up over that. They know it's within range, so it's acceptable, 0.816 or 0.815. Okay, so is there or is there not sufficient evidence to support the claim? So very similar to, when we first learned this in chapter 8, we're going to need our p-value. So I know they have the critical value method here when you find your R, and then you have the plus and minus values, but inside of the exam, those are not necessary. You do not have to find that at all. But we will use the p-value. Like I said, it's very p-value heavy. And our p-value here is going to be 0.0022. You can see it here in the calculator. So, So is there or is there not? So as you may recall, we have to compare this against our sig level. Where's our sig level? Right here, 0.05. So 0.0022 is definitely less than 0.05. So there is enough evidence to support the claim, just like we did in the last chapters and in the last videos. So you want to say that there is sufficient. So it's either going to be D or A, right? We know it's D. So let's go ahead and compare D and A. It says there is sufficient evidence to support the claim of a nonlinear. No, never choose nonlinear. Okay, you always want to choose linear. So there is sufficient evidence to support the claim of a linear correlation between the two variables. That's it. C, identify the feature of the data that would be missed if part B was completed without constructing the scatter plot. So let's look at the scatter plot. Okay, this is they call this parabolic. It's curvy. It's not a straight line like these guys over here. Basically, you want to put that into words. So it says the scatter. This is always going to be the answer. Okay, whenever you have a parabolic thing like that, so it will be on your exam. The scatter plot reveals a distinct pattern. So this is definitely a distinct pattern, right? There's no denying it. It made a pattern. It made a curve. But it's not a straight line pattern. So you wanna, jot this down. That will be on your exam. Okay, so we've done question 5. What else do I have here? I wrote down. I believe I sent you guys the ones to worry out for. Yeah. So we have question number 6 as well. All right, so a number like 6. Why did I put 6? Yeah, all right, we're gonna go ahead and do 6. Okay, shouldn't be too bad. Let's just construct the scatter plot. So let's go ahead and see what data we're working with. Take a look at this. I don't believe your exam had confusing values like these where they give you like multiple ones to work with. Here's how I want you to tackle this, right? First of all, it's like, what do we use? Distance, time, fair, tip. you have to read and figure out which one you would use. But to save you some time, and it's in the passage. Let's see the distances. Let's go ahead and skim that. Okay, yeah. So it says, is there sufficient evidence to conclude that there is a linear correlation between time of the ride and temp amount? So there go, that's what we're going to use. That's our X and Y, time and temp amount. And if you really didn't feel like reading, which you should take this seriously. Look at your axes from the graphs that they gave you. The X is your time and your Y is your tip amount. So you can't go wrong. So that's what we're going to use. Okay. We're going to use time for our X and tip amount for our Y. So when you're putting these inside of your calculator, let's go ahead and clear this. Let's see, hit clear, enter, highlight L2, clear, enter. Okay, so we're going to go ahead and input these values in a second. But you know what? Because some of you will be trying to complete your homework and sometimes the numbers can get a little crazy. We're going to use stat disk for this. Oh, I'm sorry. I keep saying stat disk. Darn it. Stat crunch. Stat crunch. But before we do that, I'm going to do both ways. So I can just, so you guys understand it. I'm going to put in a TI-84 first. Okay. Okay. So what do we need? We need, the ride time. So I'm going to put all the times in here for our X because ride time is in your X axis. So 6, we have 18, 31, 27. Yeah, I know it's 27.00 for your data, but it's the same thing. You don't need the trailing zeros after the decimal, right? 11, 8, 8, 2. And for our Y, the Y was the tip amount, right? Isn't that what the Y axis is? Tip amount. So let's go ahead and put those in. So we have 1. Let me go back to the calculator. 1.89, 4.29, 2.98, 0, 1.96, 2.34, 0, and 0. Okay, so we have everything we need. Let's see if it'll give us a graph that we can see with our own eyes. Not quite. Not quite. It's very close. We're going to adjust the window here for a second. Let's go to window, and we're going to set it as the same dimensions as what we see in the graph. So this is going from 0 to 35. So your X-Men will be 0. X-Men, ha ha ha. Marvel. Anyway, and your top will be 35. Your scale is going to be 0. I'm sorry, 1. Let me concentrate. Your Y-men, which is the Y-axis, the small number of your Y-axis, that's going to be 0. So put 0, enter. The top number is going to be 25, which is your Y maximum. Leave that as 1. Now when we hit graph, it's going to look exactly like we have here on the left. So hit graph. That's more like it, right? So which one closely resembles this? It looks to me like it may be choice C, because yeah, we have these points here, like 1, 2, 3, and in the calculator we have 1, 2, 3. Yeah, I'm going to say a C. So take your time and take your time and analyze your graph and compare it with what they have. Now, I did say I was going to use stat crunch, right? So to use stat crunch, and I'm going to have to set up another window right quick so you guys can see. Give me 1 second. So to go to stat crunch, you go to this little dialog here. Give me a second. I'm looking for, yeah, shout out to Michelle from the WhatsApp group for explaining the Excel portion. You're the MVP for that one. but we're not able to use, we're not going to always be able to use Excel, but that's really good for you guys with the homework. I'm going to show you guys how to use StatCrunch though. Okay. So take a look at all this, right? It's like, which one do we use? So remember, we already, wait, oh, you guys can't even see it. All right, let me set this up. Open a StatCrunch. We're going to go over to, now, if you don't need to use StatCrunch, if you just want to use the TI-84, that's fine. You can just fast forward to the next portion, to the next number, because this is going to take me a while to set up. But anyway, window capture. All right, let's hit OK. And did I get it? Yeah, I got it. Haha. All right, good. Let's bring this over here. All right, I think I nailed it. Now, usually it's in the form of a, usually they go by columns, but looks like we only have rows here. So bear with me here. All right, let's see if they'll let us get away with it. To find our graph and everything that we need here, we're going to go over to regression, simple linear. So it's saying, what is the x variable? Now, the x variable has to run from left to, oh, they're not going to give it to us because this is running from left to right. Yeah, this is saying var1, right? But var1, that's just the row here. I'm not sure how to put in rows. Looks like I can only put in columns. Okay, this was a pretty bad example. Okay, sorry about that. But the numbers are here. Okay, this is pretty bad. I'll take the L today because I don't know how to put in columns as opposed to rows. Yeah, that's lame. Maybe we can, if I click on this, maybe we can. No, we cannot. Let me see if I hit. No way. Flawed program. Anyway, hopefully in the next one I'll be able to show you guys how to do that. Well, we have what we need. We use the trusty TI-84. Anyway, this is why I hate this. Let me just set you up for failure. Maybe it's my ignorance because I don't know how to put rows in as opposed to columns, but they knew exactly what they were doing, in my opinion, and that's just lame. Anyway, the linear correlation coefficient, to get to it, we go to our TI-84. Let's click on it. Let's hit stats, tests, lenred t-tests, and we're gonna go down to calculate. It's just so much quicker. Anyway, yeah, here we go. So linear correlation coefficient is going to be R. So 0.298. They wanted 3 decimal places. Let's do it. So 0.298. Can't believe StatCrunch didn't work. I hate StatCrunch sometimes. Okay, whenever they give you these, the null hypothesis and the alternative hypothesis notation stuff, just very robotically put the equal to, the cannot equal to, 0, 0. You guys remember this, the two-tail test, stuff. All right, check answer. Excellent. All right, test statistic is right here in our calculator. You just go ahead and look for T. There it is. How many decimals? 1 decimal? 2 decimal places. So 0.76. So if you master the TI-84, you'll be able to pass your exam with an A. P-value. P-value is right below your test statistic. They wanted 3 decimal places, so 0.473. Let's put that in 0.473. Fantastic. Okay, now this stuff. So remember, the p-value here is actually greater than your significance level here. So this is a fail to reject, and when you fail to reject, there's not enough evidence to support the claim. Remember that. So there is not a correlation. So in this section, remember, you're wondering if you're trying to figure out if there's a correlation or not. Anyway, determine the proper conclusion. Since the p-value is greater than a sig level, there is not enough evidence to support the claim that there is you have to put a linear correlation between the time and write between the time of the write and tip amounts. It appears the writers do not base. Yeah, you have to say do not because we just failed to reject. Good job. It's good when it's consistent. Okay, what else we have? This is a very similar question, so we don't have to go over this one. I have number 11, which is definitely going to be on your exam. So let's go all the way to 11. Remember, like these concept questions here, just write them all down, take a photo of them and study them over and over. Like these are easy points, you know, it's just memorization. It's not mathematical. When determining whether there is a correlation between two variables, one should use a scatter plot to explore the data visually. Very important. A visual representation, that's a graph, a scatter plot. So if you see this on your exam, you know, you want to always choose this one. So these concept questions, you know, just memorize them, write them down, do what you have to do, drill them into your head. The real brunt of your exam is going to be whether or not you can find the R values and stuff like that. Okay, so let's take a look at this one, for example. This is definitely on your exam. I saw it. Okay, let's see. Okay, what does the symbol Y with the caret represent? Okay, this is called the predictive value. Okay, it's always predictive value. So once again, this is a, you know, there's a bunch of concept questions here, no math involved really. So you want to choose predictive value for that symbol because that's what it is. Now, notice that we also have a predictive value here, but it says of weight. The predictive value is always based on your Y. So if you click on this table here, right? This weight right here is actually your X because it's the first one. This over here is your Y. So it's always the predictive value is always based on whatever your Y is. Okay. So because that's what we normally use. We don't use the predictive value of your X ever. Okay, so always focus on your Y. It's always Y equals, okay, Y with the caret. So know the category. This is the Y column. So make sure you use that as your predictive value anyway. Yeah, so know the distinction. What are the specific values of the slope and y-intercept? Okay, so back to your, for those of you who've taken algebra back in high school, maybe algebra 2, the number that is always next to your x is your slope, okay? So, and you also want to make sure that you put the appropriate sign. If that's a negative in front, you better have a negative in your answer. So the slope is always what's in front of the x, not the x itself, but what's in front of the x. That's negative 0.00749. So your slope should be negative 0.00749. Notice they also give you a positive value. That's to trick you. Okay, I hate to say it, but yeah, that's to make you get it wrong. So you want to include the sign. All right, if it's positive, leave it as a positive, but this is negative, so make sure it's negative. The y-intercept is the number without the x, 58.9. So there it is. That's why this answer here is B. Okay. What is the predictor variable? Now, they call it many things. I'll upload a screenshot that I took. They call the x variable many things, but that's what it is. It's represented by x. And remember, this is based on the category of weight because that was your first column. Okay. So that's, remember, weight is x. Whoops. Weight is x. Highway fuel consumption is your y. Yeah, I'll upload it to you guys so you can see they call it many different things. It's kind of ridiculous in my opinion, but I guess the more the merrier. Yeah, I found it. They also call it the independent variable. So x is also your independent variable. X is your explanatory variable, and it's your predictor variable. The dependent variable is your y because y depends on whatever x is. So if x is 3, you plug in a 3 and that's how you get your y, for example. So yeah, that's it. I will upload that screenshot later so you guys can see. Okay, but anyway, the predictor variable is weight, which is represented by, yeah, so that's C. Okay. assuming that there is a significant linear correlation. So they already did the test for us, and I guess their p-value is less than the sig level. Okay, hypothetically. So what does that mean? If there is a correlation, basically you're allowed to use this equation. If there is no correlation, like if your p-value is greater than your sig and you fail to reject, then you have to find the mean of your y. So we're gonna come across that. I've already picked out some questions for both cases, so fear not. Okay. All right. So anyway, there is a significant linear correlation between the two sets of data, right? So we are allowed to just plug the number into this equation, and that's it. So what do we get? Let's plug in, and they want us to base that on 2,990. So let's go to our trusty TI-84. Okay, got it. All right, so let's go to our trusty TI-84. What the hell is going on? Anyway, I keep misclicking everywhere. Anyways, let's say clear. Okay, so we are allowed to actually use this equation. So let's type in equation. So 58.9. I think something's going on with my laptop. All right, minus 0.00749. And right where the x is, you use an open parentheses, and you're going to plug in the 2,990. Close it up. Enter. There it is, 36.504. Yeah, that's it. All right, so one decimal place, that'll just be 36.5, as you can see right here. So if there is a correlation, if you did the p-value test and there is a correlation, then you're free to use the equation that they gave you. And you can just plug the number into the equation. But you're going to see, like coming up, that if there is no correlation, you have to find what the mean of your y's are. So you will find the mean of this. And remember, we can use one of our stats, put the stuff in, and we'll call it a day. You know, since we're here, right? Let's go ahead and use StatDisk, because they actually gave us columns this time, which they should each and every time. Yeah, let's go ahead and do StatDisk for a second. Damn it, StatCrunch. Keep saying StatDisk. What the heck is wrong with me? Okay, so we have StatCrunch. Okay, so let's go ahead and go to stats. We're going to go to regression, simple linear. What is your x variable? Your x variable is your weights. You see how nice it is? They gave us actual columns to work with. Okay, your y variable is highway fuel consumption. And all you do is go to compute, and look at that. All this nonsense, right? But let me take you back to what we were working on. Let's exit that out. Okay, so take a look at what they have. They have 58.9 for the equation, and we get the same equation. So to read this, and it's a little weird how everything is weird about stats, right? The way that they set it up, they put the 58.8 like right here. And I guess you can get it from right here. It says intercept. There's the intercept, the 58.9, and they also have it inside of theirs. So they've already went through the trouble of finding it for us, but I'm just showing you how to find it yourself with given data. You see the slope is negative. So that'll answer question B, where it says what are the specific values of the slope and y-intercept. So your slope will be here, your slope will be here, your y-intercept will be here. They also put it up here in this form. Here's the value of the slope right here, negative 0.7, and they put the word weight next to it. You can think of that as being x. And look, the graph as well. This is how the graph will look. So in StatCrunch, you will click between these two arrows. Let me make sure you guys can even see this. Yeah, you can see it. All right, so you will click between these two arrows, and that will give you your stuff you need. The p-value, very, very careful. Choose the p-value that's down here, okay? In my experience, that sometimes those numbers can change. I don't know what their deal is, but choose the one that's down here to the bottom right. And I also noticed that these two will be the same. So if you prefer, choose the p-value that's down here, okay? It's not as nice and neat as the TI-84 is, but we got the answer, and that's the most important thing. All right. Finally, I'm glad I was able to show you guys an example from StatCrunch that actually gave us freaking rows to work with. But anyway, let's keep on going. All right, so I have question 11 down here. What else do I have? I have also 13. So number 13. Let's go to 13. Okay, yeah. So this is a concept question. This question was on the exam. The value of R will always have the same sign as the value of B1. Okay, so write this down, copy it, do what you got to do. All right, I have 14. I put maybe next to 14 because if you get the concept, you'll do better on your exam, no doubt. I'm not sure if this specific question was on the exam, but let's pretend that it was. Okay, it's asking you to find the best predictive value of Y with the caret for an adult male who is 147 centimeters tall. So the question is, can we plug in this 147 into the equation, the predictive value equation, or do we have to find the mean of the Y? So it'll be real nice if they gave us the mean of the Y. And look, they did. They gave you the mean of X, which is useless to us. And they also gave us the mean of Y. So, notice that is the answer, 81.33, right? They're the same. The reason why is because this had to have been a fail to reject type of problem. So how do we prove that? Take a look at your p-value. Your p-value, 0.289, is greater than your sig. So you know what that means? You're going to fail to reject, which means that there is no correlation, which means that you cannot use the correlation line, this regression line here. So another thing, look up the definition between correlation and regression. I know I shouldn't put them both together like that, but I'm just here to help you get an A. All right, anyway, so your p-value is greater than your sig, so this is a fail to reject, so you cannot use your equation, so you're forced to find the mean of whatever your Y is. What is the mean of your Y? They gave it to us, 81.33, so that's the answer, okay? Now, let's say that there was a correlation. If there was a correlation, then you're free to use this equation here. You would just plug in whatever your X is. So you would have plugged in 147 right into here to X, plug it in, hit enter, and that'll be your answer. But because there is no correlation, you have to just find the mean of your Y. And yeah, that's very important. Very important that you get that concept. It's either you're going to use the equation or you're going to use the mean. So you have to know which one is which. And you base that based on the p-value test. Okay, what else I have? 16. So let's go to 16. Okay, so yeah. So number 16. This is very good. This was definitely on the exam, so it's time to study up. Okay, what do we have here? Let me make sure you guys can see. Okay, so we have two sets of data, right? I'm going to go ahead and make quick work of this inside the TI-84. So you go to stats, edit. Let's clear everything. Okay, so we have 45, 50, 43. The numbers are short, so yeah, I'm willing to use this over StatCrunch. All right, let's move over to 352, 374, 275, 314, 440, and 367. Okay, so you know what comes next. Let's hit stats. We're going to go over to tests. Go over to the linear regression t-test. Go all the way down. Hit enter. There goes our stats. Okay, so it says, what is the regression equation? You need your A and B. So you can see at the very top it says y is equal to a plus bx, right? Basically, whatever your A is, you want to put over here, negative 172.6. Yeah, there it is. You see we have A equals negative 172.6. So if you have good eyes, if you can see, you should be able to get this right. Not trying to be funny, but yeah, I'm being funny, but I'm being serious as well. The answers are here. If you can go to linreg t-test after putting in your data, you can't go wrong. Your b is always next to your x, so that would be your slope, and it's positive 11 point. They wanted 1 decimal place for both of them this time. You see right here, 1 decimal place for both. So that's just 11.1. Okay, so is there a correlation? So this part, what is the best predicted weight of a bear with a chest size of 51 inches? So are we able to use our equation or not? Well, what is the p-value of here? Likely the calculator gives us a p-value. It's up here, 0.03. We have to compare that with our significance level, 0.05. 0.03 is less than 0.05. So there is a correlation between the two. And because there is a correlation, we are allowed to use our equation. We just plug the number into the equation. So we have 51. We plug it into the x, and that would give you your answer. So the equation we have is negative 172.6 plus 11.1. And you can use an open parentheses to put the number in, or you can just hit times because it's multiplying. And they want us to put in 51. Hit enter, and that's how we get the 393.5. Easy, right? So you have to know whether or not you're going to use the equation or you're going to use the mean. So hypothetically, if there wasn't a correlation, we have to find the mean of our y value. Which one is our y value? The y value here is the weight. So take a look at your data. Your L2 is your y. Your L1 is your x, so your L2 is your y. So we would find the mean of our y. Let me just show you how to do that. Let me refresh your memory. You go to stats, you go to calc, you can go to 1var stats, or, since we're here, let me show you how to do it. 1var stats, make sure you put your L2 in there and not your L1. Please don't make that mistake. Jot this down, dude. You're finding the mean of your y. So you want to put your y data in here, and your y data was your L2. Just hit enter, and your mean is at the very tippy top. It'll be 353.67. If you didn't want to use 1var stats, you can go over to, like from here, you can just hit, let's go to the main menu. You would hit second stat instead, and you would go to where it says math, and you would click on mean, and it's asking you what list do you want to put in. So from here, you can put second L2, close it up, and it'll give you the same thing, 353.67. So just let that save you some time. Practice that. I know there was at least one question on the exam that required you to find the mean. If not, maybe don't quote me on that, but you still want to know this material. Maybe it'll help you out to complete your homework as well. Okay, is the result very close to the actual weight of 352? So we're basing that on the 393 that we got. It's close, but not quite close, right? So to me, that's very subjective, but look, just memorize this type of question, and you can't go wrong. So yeah, it's not very close. That's that's a matter of perspective to me, but whatever. This is the answer, okay? So that's it. Okay, what do we have left? We have 16. What else do we have here? 16, 17. Okay, so number 17, very, very similar to what we already had before. So you can put this inside of your TI-84. You're going to get everything here. They gave us, let's see if they'll let us slide with the stat crunch again. All right, it popped up. All right, good. Okay, so they gave it to us in the form of columns, which is what they should have done since the beginning to make it easier on us. Yeah, so you go to regression, simple linear. Put your X as your best actress. For your actors, put your Y. I just go all the way down to compute, and there it is. Okay, so there's your equation. You see we have 54.929, and we also have that over here, 50, round to the proper decimal. Now, very, very, very carefully. Okay. You don't want to get this question wrong. You see, it says round the y-intercept to 1 decimal place, but round the slope to 3 decimal places. Take your time and round according to what instructions they give you. Okay, I can't emphasize that enough, because you don't want to round both of them to just 1 decimal place. Okay, as a matter of fact, I think this question is, yeah, I think it is on the exam. I think so, but yeah, just be careful. Okay, they gave you 2 different rounding instructions for 2 different numbers, so you want to take your time with that. All right, jot that down. Jot that jot that warning on top of your notebook or something in your notes. Anyway, so looking at our stat disk, yeah, we have our slope and everything. So yeah, intercept is 54.9, slope is negative 0.237. Make absolute sure you put your negative. Okay, now the graph, just in case they want you to get a graph, just hit this arrow and there's your graph. And I believe that is all you have to worry about on this exam. Still, if you're doing your exam, I'm assuming that you try to complete your homework. Yeah, stick with the tips I gave you, and you should be fine. You should be fine. Thank you so much for watching.